Before we do, we are going to take a selfie. So for everyone walking in the room, even if you're walking, you can smile. And I have to set this up here. So we'll try to fit everyone in. Everyone try to squeeze together, make a smile face. Ready? 1, 2, 3, 4, 5. That's OK. I got 3 pictures.
All right, give yourselves a hand.
Thank you. Woo. Your homework starts now.
Yeah.
All right, I'm going to put this away. And now we're going to go ahead and move right into it. So first off, I am Jessica Dean. I am a cloud developer advocate here at Microsoft. A little bit about my background. My background is all Linux, open source, containers, which is convenient because I'm doing a containers talk, and IT operations. I also work on a DevOps-focused team, but I'm often asked why I don't have DevOps in the first bullet point. The reason why is because every single thing that I do, DevOps is implied. DevOps is more of a mindset, a culture, it's a choice, it's something I'm proactive in, and we're going to talk about why that's important today. Non-related to tech, I'm also super into CrossFit and fitness. Pretty much any city I go to, hotel I go to, continent, country, you name it, I will drop into a hotel gym or a CrossFit gym and usually end up scaring everybody in there because I'm upside down doing handstand push-ups or falling over after I get off the assault bike, all that fun stuff. I also am a huge Disney and Star Wars fan, and I don't say that lightly. I actually have Han Solo's blaster tattooed on me, Luke Skywalker's hilt. I have what I have been told is the most epic fandom crossover tattoo, complete with the Doctor Who, Gallifreyan language, Star Wars quotes, Princess Bride, Harry Potter, Zelda Master Sword, Lord of the Rings, you name it, I'm a geek. I am also a member of what we call the League of Extraordinary Cloud DevOps Advocates, or as we just refer to ourselves, the League. I'm going to talk a little bit more about that after I introduce Steven. Before I do, down at the bottom here, you can follow me on Twitter, Instagram, or GitHub at JLDean. No relation to James Dean, so my last name is spelled with 2 E's. And with that, I'm going to go ahead and let Steven introduce himself.
So, similar story to Jessica. I am not near the fan that she is of Star Wars, but I am a fan.
Most people aren't the fan.
Yep.
It's OK.
I am though sporting my Darth Vader socks.
He did that for me.
I did, and my background though is more on the ops side from the Windows background and open source as well. I've got a little boy at home, and I'm still married, at least as of this morning. And we'll see after the end of the week. And I'm also on the team with Jessica as part of the League.
So with that, let's go ahead and talk about the League. We are led by Donovan Brown, who you may have seen in yesterday's keynote. Hashtag black shirt, hashtag rub DevOps on it. We also have Abel Wang, we have Damian Brady, obviously Steven, and myself. But what I love most about this picture is that, first off, we are the DevOps Cloud Developer Advocacy team at Microsoft. But this picture really embodies and embraces and truly displays what DevOps is for us. So Abel, Damian, and Donovan all have primary developer backgrounds. Steven and I just introduced ourselves, and our backgrounds are very primary ops, or not traditional developer, but we would develop infrastructure now. So here you have developer and operations not only working together, but presenting together. Abel Wang and I did a presentation, which is a deep dive to this kind of content yesterday. And so I love this picture because it really kind of shows this no wall, no barrier, DevOps culture team working in effect. Also, if you ever have a question with anything related to DevOps or pretty much anything around Linux, open source, any one of our specialties, you can hashtag LOECDA on Twitter. It is literally like our bat signal. So yesterday, true story, I got asked, are you part of Donovan's bat team? You mean the League? Yes, bat signal, bat team. All of that, it sends a message to our Microsoft Teams room where it lights up and we know that you want to talk to somebody on our team, even if it's just to chat about Star Wars, have some fun, crack some jokes. I think I'm funnier than I probably am. It's fine. However, as awesome as the League is, we are only a small part of that awesome, amazing cloud developer advocacy team at Microsoft. The larger cloud developer advocates, or hashtag Azure Avengers, follow Azure Advocates on Twitter. There's about 60 of us worldwide, and we're growing. And the cool thing is we have people that specialize in everything, from high-scale big data, IoT, machine learning, AI, you name it, things that go way over my head for people that are way smarter than me. We have something for everyone on our team.
All the different language communities?
All the different language communities. It's cool because we're also, since we're located around the world, we cover every time zone, every language, every continent. It's awesome, and it's awesome to work for this team. But without further ado, you guys are obviously here in a room to learn about containers, DevOps, all this stuff in Azure, right? We keep hearing the word containers, we keep hearing Azure. Let's get started. Before we get started, though, we do have to talk about the current state of technology and the current state of our industry. We are going digital. This is a slide that is produced with data from a Gartner study a few years ago. They estimated that by 2020, 1 million devices per hour would be coming online. I'm just going to repeat that. 1 million devices coming online by 2020. It's 2018, and it's almost June. That's in less than 2 years. That's a lot of devices. They also estimated that by the same year, the average age of an S&P 500 corporation would be 12 years of age. Compare that to the 1960s, when the average age was 60 years old. Companies are getting younger. They're spinning up quicker. We have more and more devices coming online. And then the last statistic, 60% of computing would be done in the public cloud by 2025. It's about 7 years away. It's not that far. And we're already seeing such a shift to the cloud. So I actually would argue that that percentage is a little low. You have everybody talking about the cloud. Your grandmother talks about the cloud. But when she does it, she uses air quotes. Now, fun story about the cloud. I was in Paris in March presenting at Tech Summit Paris. And I had breakfast at this little cafe, and I noticed that the table next to me actually spoke English. So I got really excited because my French is awful. So I leaned over and I started exchanging conversation and tried to figure out where they were from and what they're doing there. The daughter was on spring break and vacation from college, and they were just coming to Paris. So they asked what I was doing. I said, well, I work for Microsoft, I travel, and I speak. They're like, oh my gosh, do you know where the cloud is? And I laughed. I was like, actually, I do know where the cloud is. It's in Azure. And they're like, no, that's wrong. I looked at them. They're like, I'm going to tell everyone I know where the cloud is, and I met the cloud, and the cloud's name is Jessica. I'm like, OK, that's awesome. That's a funny story, but it's true, right? Everyone's talking about the cloud. But what does that mean? So let's talk first about what we're hearing and why this matters, why the cloud matters. Out of everyone in this room, and I know we're at a developer conference, I know this is Build, how many people would identify themselves as a developer? OK. How many people would identify themselves as IT or operations, maybe? OK.
Oh, awesome.
So that's actually more than I expected, but that's great. So for the developers in the room, or even operations, even if you kind of are a jack of all trades, you wear multiple hats, tell me if this sounds familiar. I need to create applications at a competitive rate without worrying about IT. My applications run smoothly on my machine, but when it hits your server, they break. It's your problem. It's not mine. Or my productivity and application innovation become suspended when I have to wait on you. You, IT person, are the bottleneck to my success. Don't worry, IT, I'm getting to you. You guys get your moment, too. Here you go, developers. Ready? This is what we think. I need to manage servers and maintain compliance without disruption. I can't just give you access to RDP and do whatever you want with my servers. But I'm also not a developer, so I'm unsure of how to integrate this kind of application. I need to work with you. I need you to teach me and help me understand so we can fix this. But I'm also unable to focus on both server protection and application compliance. I can't worry about the security of my servers and the security of your app. Sound familiar? Mm-hmm. Regardless of where you fall in this technology field, and I know this says IT stress points, I'm not just talking to IT. I'm talking to every single person in this room. If you touch software, if you use it for either standing up infrastructure or you write code, you do something with it, these are your stress points, right? You have to worry about security. You have to worry about efficiency. And you have to worry about supporting this innovation that we just talked about in the Gartner slide. So that's why cloud is important, because cloud is a new way to kind of think about data center, right? The traditional model was that you had dedicated infrastructure for each application. The hardware you had was purpose-built for that project. The infrastructure and operations teams were distinct and separated. I often use an analogy of it's like a sixth grade dance. You have people on one side of the room, people on the other side of the room. No one wants to come together and hang out. But what you also have to realize, it's a choice to stay on either side of the room. And then the processes and configurations you had were customized, and they were specific to each project. But that model isn't scalable. It can't grow. It can't support that rapid innovation and that momentum that we've already started picking up. So that's why the cloud model is important. Now you have loosely coupled apps and microservices. The hardware is now industry standard, right? Azure is your computer. The DevOps teams that you have are service-focused DevOps teams. You're now hearing multiple companies, let's implement DevOps. Let's break that wall down. Let's have people make the choice to come into the center of the dance floor. And the processes and configurations you have are standardized instead of customized. So that really sets the stage for DevOps. And DevOps will set the stage for containers, and it's going to be cyclical. We're going to talk about it. So it starts with people. We know that because we just talked about it, developers and IT. And then we have to go through a process, right? There has to be something that's standardized across the board that can be repeatable, that can be recyclable. And then we go into products. Now, my boss, actually, Donovan Brown, was the one who wrote this particular quote. You might have seen little Dono dude floating around. I think it's so cute. I love it. But let me just read this to you. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. Now, a lot of people have seen this quote, but not a lot of people know that Donovan spent 30 days writing it because he wanted to make sure that every single word in that quote was something that he could stand behind, was something that the team and the league that he leads could stand behind. We're specific when we use the word products. Why not tools? Well, when you think about it in building a house, I can have a screwdriver, I can have a hammer, I can have a miter saw, I can have all these tools. But without products and process and the right people, I'm not going to be able to produce anything of value. I can't build a house. So here's that plan that we talked about. It starts with planning. It starts with having an idea. And then you have to go into your develop and test. This is your routine. This is that cyclical, we're keeping things moving. But that's part of your development stage. And then as you start getting over into release or your deployment stage, anything that would happen in your CD process, that's where you're starting to get over into production or whatever your end environment would be. Your dev environment, your QA, your staging, canary, prod. All of that needs to still be repeatable no matter where it lives. And then the fourth and most important is the ability to monitor and learn. Can I get rich telemetry so I can figure out, am I delivering value to my end users? Standard DevOps practices. You have infrastructure as code. We're going to talk about that. That's key when it comes to containers. You have continuous integration, or your build. We'll demo that today. You have automated testing, continuous deployment, your release management. Your continuous deployment happens as part of your release management, right? You wire up this pipeline. Everything's cyclical. Everything keeps moving. You have app performance and monitoring, load testing and autoscale. All of these practices can fit in those 4 different buckets that keep your machine running like a well-oiled machine. Benefits of implementing DevOps, and this is even from a few years ago from Puppet, but you're able to have a strong IT performance and competitive advantage. Firms who have implemented DevOps practices were 2 times as likely to exceed their profitability. Most importantly, for everybody in this room, think of it from this perspective. You're able to deploy code 30 times faster with 200 times shorter lead time. You're also estimated to have 60 times fewer failures. And in the event of a failure, you can recover 168 times faster. That's huge. So now we've talked about DevOps. We've talked about these practices. We've talked about the current state of our industry. Why is that important when it comes to containers? You're going to start seeing how containers builds on those practices. Before we do, I'm going to make you guys laugh again, or I hope you're going to laugh. This was a video that we recorded at KubeCon Austin. The guy in the video with me is Eric St. Martin. I show this in every container talk I do because from a very high level, it explains basic container orchestration. To prove it, before we finished recording, or technically right after we wrapped, we went through about 8 takes. And at about the 5th or 6th take, there was a woman who kind of stood off to the side while we were filming. She had been at KubeCon all week. She was just one of the volunteers. She said, I've been here all week. I don't know what you guys do. I don't even know how to say this word Kubernetes or what. She stumbled through it. She said, but I think after watching your video, I understand. It's that things are reliable. When something fails, it's still up. It's still available. Yes, that's what we wanted you to understand. I sent the same video to my aunt, because I send her pretty much everything I do. And I get the same response every time. I still don't understand. Are you speaking English? Which is still funny, but I still send it to her. And she ended up replying, by the way, this is the level of her technical understanding. When she says that she's going to send a text, she says, send me a bubble, which is just adorable. Hashtag send me a bubble. But I sent it to her, and she said the same thing. She said, so when something fails, it's still going to work. Yes, that's the basic of it. That's the basis of it. So let's go ahead and watch this video. It's less than 2 minutes. Hi, my name is Jessica Dean, and I'm a cloud developer advocate at Microsoft here at KubeCon.
And I am Eric St. Martin. I am also a cloud developer advocate at Microsoft, but I am not at KubeCon.
Then how are you right next to me?
You're not at KubeCon either.
What?
We've got green screen and an amazing producer.
This is some really good virtualization.
So
what are we doing today?
We are going to do a live demonstration of container orchestration with something like Kubernetes.
I'm really excited. Let's get started.
Over here, we have our image repository filled with containers that we would like to deploy. Jessica is going to be our scheduler.
Apparently.
So here's our first container, and go. Bad Docker file. Okay, we fixed the Docker file, and we're going to deploy this one.
Yay!
Sweet.
And we can have multiple schedulers,
So,
especially for the sake of time.
There we go. Containers, lots of containers.
So let's make sure that we also get our bin packing in order here.
We don't want any leftover memory.
Nope. Gotta be efficient. Always efficient. Look at all these apps we're deploying. This is gonna be the best node ever. I'm so excited for this node. Look at this. It's so pretty. I can't wait to see this node done. It's gonna be my favorite node ever.
Best one. Hey, Zach.
What's up, man? What are you guys doing?
We're talking about container orchestration.
Yeah, we just deployed a node on the server. We just deployed a bunch of apps.
I mean, really neat. Do you mind if I wait?
Well, actually, now we have node failure. What are we gonna do?
I don't know.
We actually have a Kubernetes cluster.
That's right.
So, want to see what happens when?
Yeah, so let's go over to our other node. Look at that, thanks to Kubernetes, we've taken all of our failed containers and now we migrated them over to this awesome second node. This is fantastic.
It's magic.
I really hope that this helps explain how orchestration works. Thanks for watching, social media. And thanks for watching, Seattle. Everyone can laugh. I do not mind being laughed at. I actually said that yesterday on Channel 9 after I did a really crazy dance. She's like, you know I own this footage and I'm going to post it. I said, that's what I expected. So again, that video is meant to be funny, but it's also serious. You'll notice certain things I said we're going to talk about in some of these slides. So why containers? Remember the pain points that we talked about earlier for developers in IT? Containers enables this write once, run anywhere mindset. It enables microservice architecture. And it's great for dev tests of applications and services, but it's also production realism. For operations, the biggest benefit is portability, portability, portability. You're now able to have standardized development, QA, prod, all these different environments. And with containers, your runtime environment is encapsulated. So if it works in dev and QA, it's going to work in prod because everything's nice and neatly bundled. And we'll talk about how that works. So for some of the people in the room, you might still be new to containers. You've heard the word, but you're still not 100% sure what a container actually is. So what is a container? First off, containers is operating system virtualization. Very simply put. Traditional virtual machines is hardware virtualization. You also have Windows Server containers, which will give you maximum speed and density. And then even with Windows and Hyper-V containers, you also get isolation and performance, because now you've isolated the kernel with the container. But that still doesn't explain what a container is. I'm going to blow people's minds. It's not a real thing. It is an application delivery mechanism with process isolation, and it's actually based on several Linux features. So a lot of these words are things that you'll hear in association with orchestration tools like Kubernetes. You'll hear namespaces. That's what a process can see. You might even hear C groups. That's what a process can use. So that's things like memory and CPU and devices. Namespaces gives you access to PIDs and mounts and network and, again, users and C groups. Now I always get asked is, OK, so process isolation, starting to understand, but then what is Docker? You keep talking about Kubernetes, and you keep talking about all these other tools and containers. How does Docker fit into it? Why do I need a Docker file? First off, Docker is an open source container runtime. It has Mac, Windows, and Linux support. It is a command line tool as well. So you have a GUI, but you can do Docker commands. And then the Docker file format is used for building container images. The Docker image format uses also a layered file system. So we'll talk about that, especially with caching layers. So here's what a simple Docker file looks like. And it might look scary, especially for any IT pros in the room or developers who have never written it. We're going to talk about not only how to create this, but with how to create it without writing one single line of code. And Steven's actually going to demo that in a second. Yeah. So first off, you have a Docker file. You have your structure. You're doing from. You're doing a command, whether I want to copy, whether I want to add, whatever I want to do. And then I can run a command, and that would ultimately end up creating my hello world Docker file application, which when I run it at the bottom would just give me hello back. That's all it's going to give me. But that's a Docker file. But here's how this is working. So Docker, as I mentioned, uses a layered file system. So you kind of take a base image. So in this case, it's based on Ubuntu's 15.04 image. And then you have all these layers that are kind of cached on top of it, all these different parts that's needed for this image. And these are read-only layers. But where read-write ends up happening sits on top of the flattened layers. So you'll notice when you're going through your build, when you have a Docker file and it says it's building and pushing an image, it's going to say it's building and it's pulling this layer and it's pushing that layer. Those are layers and caches that it sits, so it makes it easier to manage. Now let's take a look at what virtualization versus containerization looks like. So traditional virtualization, you have two different types, right? You have hardware with your hypervisor sitting on top of it and VMs. You might think of that like VMware, ESX, or ESXi. Or you can think of it like maybe with hardware, host OS, hypervisor, VM sitting on top of it, perhaps Hyper-V and Windows Server. And then you have the guest OS and dependencies and application, and it's a lot to manage. But with containerization, you have hardware, you have your host operating system, you have the Docker engine that sits on top of that, any dependencies sit on top of your engine, and then you have little kind of containers on top of that. And what a container is made up of is your app dependencies, that's also layers that it pulls, and then your application itself. And all of that's defined as part of your Docker file. So again, we still talked about these problems and pain points that developers and IT pros have, right? So here's why containers are important. Here's the advantage of using containers. You have fast iteration. It's agile delivery. You have immutability. You have cost savings, efficient deployment, and elastic bursting. And elastic bursting is where you can go from private cloud, if you're running a private instance of Kubernetes or private cluster, and actually burst into public cloud based on CPU demand. So that solves issues for both developers and for IT, right? It's trying to meet those additional requirements or the additional needs. So now I mentioned that Steven's going to show a demo of how to create a Docker file without writing one single line of code. So I'm going to go ahead and switch over to him real quick.
There we go. All right. So I'm going to show, I've got VS Code open here, and I've got a little Node.js app. It's a pretty basic Node.js app, but I'm going to do some local dev work like I do. And when I'm doing my local dev work, I like to be able to run my app, do debugging, that kind of thing. And let's just make sure that everything all works. So I just hit F5. And it looks like we got things running. Let's see if my app runs. Hey, that's some pretty fancy ASCII art.
By the way, that's using a Node app, and the dependency is Figlet. It turns all your text into ASCII. And I'm a huge fan of anything ASCII and binary, so much so that I have binary tattoos tattooed on me. Told you I'm a geek.
All right, so hey, nothing special about being able to run a Node.js app locally. But we want to take advantage of containers, right? We want to take advantage so we can get a lot of the benefits that Jessica was talking about, and so we can start playing around and trying this stuff. Well, VS Code has some stuff to help me. So there's an extension. There's a Docker extension in the marketplace. I've already got it installed. I also have Docker for Windows installed on this machine. And with that extension, I can go to my command palette and start typing Docker. And I want to add Docker files to this workspace. Now, there's actually a bunch of languages supported by default. Go, Java, .NET. We've got Node.js. Let's see what that does for us. What port does my app listen on? 3000. That sounds good. It's almost like that was
planned.
Set, yeah. Funny how that happens.
We wrote it port 3000, so we entered it. And look at that. It actually added the Docker file and even some Docker Compose files.
Yep. So there's a couple of files that were added. Didn't have to do much of anything. But now that I've got these Docker files here, what can I do with them? Well, I can spin up my app, and just to let you see here, there's these two Docker Compose files. There's a Docker Compose.debug YAML and a Docker Compose YAML. The debug YAML is the important one here. This is so I can actually run my app in a container and get local debugging, so that I'm going to run like I'm going to run in production, but I also have my same local dev experience. So to get that started,
and again, just to clarify, he didn't write one line of code. That was from the Docker extension.
I'm going to use the command palette again, and there's a Docker Compose up. It lets me pick the Compose file I want to use. I'm going to spin up the debug one.
So you don't have to know that command line. It entered it for him.
Yep. And what it did is it built my container and started running it on my local Docker instance. So now I have a container running, and now I want to start debugging. So we go over to our nice little bug picture here, and I'm going to move this over so we can see. Now, it says no configurations, and in order to debug into a container, I have to create a configuration so that the debugger knows where to go. So I'm going to add configuration. And one of the first suggestions it has for me is Docker attached to node. So all I have to do is hit enter, save, and I'm ready to debug into my container. So I can pick Docker attached to node, start debugging.
And while that's loading, that functionality for him to add that in was added in and provided again from the Docker extension. That's not anything that's a keystroke or anything on our end. It's the Docker extension for VS Code.
So I'm going to set a breakpoint right before the Figlet call. So when I refresh my browser, then I should get my browser spinning, and I should see the breakpoint being entered, right? So let's see what happens.
And I see it flashing right down there. So what happens when we click on it?
Let's see. All right. We are now debugging the application running in the container. So
built from the image that the Docker file for VS Code created for us.
Yep. And we have access to local variables. We have the call stack, all the experiences that we would normally have when we're debugging locally.
So that part's really cool. It shows us, OK, we can take this application that we're used to working in our dev experience. I kind of want to start learning this container stuff. I want to start doing these DevOps things, but I don't know where to start. So VS Code will create the Docker file for me. I've now done, as a dev, I've done all my local debugging. I know that this app is now working in my Docker file. I feel proud. I didn't have to write one line of this Docker container mumbo jumbo. But now how do I get it into the cloud? How do I run it in Azure? How do I use these DevOps practices that you've been talking about? So to set myself up for this, I'm going to add this stuff into my repository. So I'm going to commit this while Jessica starts to take us down deeper into what we're going to run. Do you want to show us the git commit from VS Code?
Well, I'm a command line guy.
As am I. Hashtag no clicky clicky. So just basic git commands, right? We're going to add our files. We're going to add a commit message, and then we're going to go ahead and push.
Yep. So
that's it. So it's up in GitHub. It's not linked up to any kind of CI/CD pipeline. We're going to show you that in the next demo. But the first thing we want to do is we want to make sure that we talk about container orchestration before we dive deep. So here's elements of container orchestration. First off, Kubernetes is not the only orchestrator. You have DCOS, Mesosphere, you had Docker, Docker Swarm, Swarm Mode, there's Pivotal Cloud Foundry. There's all these different orchestrators, right? What makes up an orchestrator? Elements of orchestration. You have scheduling, you have affinity, anti-infinity, health monitoring, failover, scaling, service discovery, networking, coordinated app upgrades. Tell me if any of these words fit into those buckets of standard DevOps practices that I talked about earlier. Starting to see the connection here, how things are linking. But we are going to talk about Kubernetes, because it is the de facto orchestrator. Why? First off, it's portable. You can use it public, you can use it private, you can use it in hybrid instances, you can even use it in multi-cloud instances. It's extensible, meaning it's modular, it's pluggable. It's also self-healing. When you use a managed instance of Kubernetes, right? You can have auto placement, you can have auto restart, auto replication, auto scaling, which is really nice. It empowers you to do more. So what do I mean by that? First off, you can deploy your applications quickly and predictably. You can also scale your applications on the fly. So a lot of the things that go back to Kubernetes is you're starting to implement things like infrastructure as code. You start having these YAML files and these deployment files and these service files. Everything's repeatable and recyclable. As such, you can roll out features seamlessly. You can also limit hardware usage to required resources only. Because remember, we talked about container advantages. It has access to the C groups. It can see the hardware. It can see CPU. It can see memory. I can define that as part of my deployment. So let's dive even deeper into container orchestration, focusing on Kubernetes. First off, what is it? Flat out, Kubernetes is an open source container orchestrator that automates the deployment, scaling, and management of applications. It was originally written by Google. Yes, I'm at a Microsoft developer conference talking about something that was written by Google. Mind blown. It was donated to the Cloud Native Foundation. As of March of this year, it was the first project to graduate from the Cloud Native Foundation. And on top of that, it's the only project, as of right now, to have graduated from the Cloud Native Foundation. If you want to learn more about the requirements of that, you can go to cncf.com. But more so, it also has really awesome features. You have automatic bin packing. Remember my video? I kept saying, let's get our bin packing in order. You have self-healing. You have horizontal scaling. You have service discovery, load balancing, rollouts, rollbacks, right? Load balancing, networking. You have secret and configuration management. So we'll talk a little bit about Kubernetes secrets. But that allows me to store, let's say, Docker registry information so that I don't have to exchange username and password in my deployment files. And I can just reference an image pull secret that's attached to a namespace that's attached to a deployment. So that way, the deployment can have access to my private registry. And we'll show a little bit about that. Why should I care about Kubernetes? Why should I use it? First off, it's agile. So you have 8 servers down here at the bottom. You have your little container orchestrator space. Here's where the containers go. Here's your happy little IT, dev, whatever kind of tech person you have. You have all these apps that you want to move over into a container orchestrator. We want to keep this person happy. Because it's agile, we're able to move it easily over into the orchestrator, and it's spaced out over our workers, over our nodes. But it's also scalable. What happens if I have more applications? I want to add more servers. Especially when I'm using a managed Kubernetes service, with one command, I can add 10 more nodes, 50 more nodes, 100 more nodes for my workers. As such, when I have more apps that I want to move in that container space, it makes it super simple to scale. And most importantly, it's reliable. So in the event I do have nodes that go down, it's self-healing. It'll spin up new workers. It'll spin up new nodes. And I don't have to worry about my apps failing. That was that funny part of the video, right? The IT person came over, messed everything up like we usually do. I was giving you one, devs. So now you might be wondering, where can I run Kubernetes? There's a variety of different options. Cloud is not the only option. You can do Minikube, which is an open source project available on GitHub. You can even use Docker. The latest Docker Edge for Windows or Mac includes the ability to set up a Kubernetes cluster locally on your system. You can do cloud. You can do Azure. We have several different options. You'll notice we have more than the others. You have Azure Container Service, or ACS. That would be an unmanaged instance, and we'll talk about that. You have Azure Kubernetes Service, which is AKS. You also have Azure Container Instances, which is backed, by the way, for those who don't know, with Kubernetes. Then you have AWS for Elastic Container Service, Google Cloud Platform, or Google Kubernetes Engine, commonly referred to as GCP or GKE. But we're going to talk about Azure and AKS. It is your Kubernetes cluster, and it is managed by us. That means that we take care of the control plane. We take care of the master nodes. And we'll talk about what that looks like. Why AKS? First off, it's easy to use. It is the fastest path to Kubernetes on Azure. You can get up and running with 3 simple commands. And I argue it's technically 2 if you already have kubectl installed on your local system. It's also easy to manage. You have automated upgrades and patching. I mentioned how it's easy to scale and move from 8 nodes maybe to 18 nodes to 50 to 100, however many you want. You can easily scale the cluster up and down with 1 command. It's also a self-healing control plane. It also uses open APIs. This is 100% upstream Kubernetes. This isn't a forked off branch that Microsoft owned and decided to do some crazy stuff with. This is 100% upstream Kubernetes. Here's how easy it is to get started with AKS. Like I said, literally 3 commands, technically 2. The first command is using, by the way, all of these commands is using Azure command line. So that's also free and open source and cross-platform. You can go download it. But you would run az AKS create. You specify your resource group name. You specify the name of your cluster. And you can even use the flag to generate SSH keys, so you don't have to provide one. It'll do everything else. And by default, when you run this, you'll get 3 nodes. It sets up 3 workers for you. Then if you don't have kubectl, which would be the local command line tool to interact and communicate with your Kubernetes cluster, you can simply run az AKS install CLI, and we'll install the CLI for you. And the final command is az AKS get credentials. Again, specify your resource group name and your cluster name. And that'll actually download your config or your context onto your local system so you can communicate with your Kubernetes cluster. And if you already have additional Kubernetes clusters in other clouds or locally on your system, it's just going to merge your context. It's not going to override anything. And then you're able to interact and get your nodes and start talking to your Kubernetes cluster. But I also mentioned it's really easy to manage. So the first command, I can run az AKS list, output is table, unless you're really adamant on reading JSON. But you can actually see the Kubernetes release that's running. If I wanted to upgrade to perhaps a different release, a different version, I can do that again right from command line with a flag. And as of yesterday, they showed in the keynote how you can actually do that even from the portal. I can go in and GUI and click if I wanted to. Again, my hashtag is no clicky clicky. But then again, I can see that when I run the kubectl get nodes, my version has been upgraded. I went from 177 to 181. And then when I mentioned how easy it is to scale with 1 command, again, you just use the az AKS scale command with an agent count flag. How many agents do I want? 10, 50, 100? However many you're willing to buy, I promise you, Azure wants to give them to you. But why would I care about AKS versus ACS? This is essentially ACS. This is without AKS, without the managed version. You're responsible for the control plane, which includes the master VMs. That also means you're paying for them. And you're responsible for your agent pool, all the workers, all the nodes. So you're responsible for your hardware upgrades, canonical upgrades, patching, Kubernetes, anything. You're responsible for all of it. But when we manage it, we take care of the control plane. You don't pay for it. All you have to worry about is this. So from developers and IT, it empowers you and encourages you to where all you have to focus is what's running in your cluster. So we take a lot of the legwork out of you, and you can focus back on delivering that continuous delivery of value to your end users. So now we mentioned that we're going to talk about DevOps pipelines and how to set up this connection to Kubernetes, right? We have the app that Steven created earlier with the debug file or the debug Docker file. But I want to run that in Kubernetes. I now know how to set up my cluster, but how do I also do all these DevOps practices that I've talked about, right? So Steven's actually going to show me how to do that.
All right. So because we want to do this in a scalable, automated way as a good DevOps citizen, we want to create a CI/CD pipeline for this. So I'm in my portal for Visual Studio Team Services, and I'm going to walk through, along with Jessica here, creating a full CI/CD pipeline for deploying a container running my little Figlet app into a Kubernetes cluster on Azure. So we're going to start out, create a project, and we're going to call it Jessica Teaches Steve Containers.
Great. So it looks like actually Visual Studio is setting up this project for us, right? It's going to set up source control repo where we have access to this. We have access to work dashboards,
work items, and it's going to have our harness for our build and deployment.
Okay.
And really get us set up for success.
So that was really fast.
Yep. Yeah, it usually goes pretty quickly.
And it looks like we actually have quite a few options for how we would want to get code in here. It looks like we can push from an existing repository that we would have on our system. We can import a repository, because as I understand it, Visual Studio Team Services actually gives us free, unlimited private repos.
Oh, yeah.
So I don't have to pay GitHub $8 a month.
You do not.
Yes. I really need to save $96 a year.
So, but our code does live in GitHub. So
we did that intentional, by the way. If you guys want to actually fork the same demo we're using, you can go fork it because it's out on a public GitHub repository.
So we're going to set up our build. And we have some options for the source. And we're going to go to GitHub. So it needs access. And I need to give it a connection name. We'll just call it demo. And I'm going to authorize it with OAuth. Now, I've signed into GitHub before, so it just picked that up, and I said it could do this before, so it's fine.
That's really fast. Now, what happens if I have a lot of repos in my GitHub? Is that going to take a while to find?
It could, potentially, but there's a handy little thing here. Click on the ellipsis, and we have a filter. So I have a lot of repos as well. And let's go and find our Node app. There we go.
Cool.
And it picks a master branch. You can tell it different branches to build. I'm going to build master because I like trunk-based development.
Now, okay, again, I'm still new. Do I have to know what I'm doing as far as tasks or anything, or is there a template for me?
There are templates. There's templates for a lot of different build types. But since we're dealing with containers, let's take a look. And we have a container build type. So I'm going to apply that template.
OK. So it looks like it actually added in the build and push task for me, because this is just a task runner on the left-hand side here.
Yep.
But what's this agent queue?
So the agent queue is where the builders are.
Okay.
And by default, Visual Studio Team Services offers a number of hosted ones where they build and manage, or they manage them for you.
So these are computers that are going to run my build.
Yep. And
Cool.
you can also have private build queues, and we'll talk about those in just a minute.
So Microsoft Visual Studio Team Services gives me a hosted Linux preview.
And hosted Mac if you want it. But we're building Linux containers, so let's use the Linux preview.
OK.
All right. Now we can dive into our tasks. So the first thing that we need to do is build an image. Now, in our repository, we committed our Docker file, right?
Yep.
So we are going to use the Docker task here to take advantage of that, build it, and push it to my Azure Container Registry.
Awesome.
So first thing we have to do is authorize one of my Azure subscriptions.
That has access to the Azure Container Registry, right?
Yep.
OK.
So I'm going to click authorize. It's going to go in the background, and it's going to create my service principals and all the authentication stuff that my build is going to need to communicate with that and set it up so that Docker knows how to actually push to my container registry.
I don't have to then add any kind of username or password information to connect to this registry?
Nope.
OK. Oh, look at that. So I can actually choose a registry.
Yep. We're going to pick my SJM demo.
OK. And I see the action, because I used a template, the action was already pre-selected for building an image.
Yep. And by default, it's got a glob on the search there, so it's going to look through your repository for your Docker file.
OK.
I like to be a little more specific about it.
Yeah,
so I'm going to go
is always
in,
better.
and so yeah, I don't like unexpected stuff happening in my builds. So I'm going to go pick what I want.
And now this is obviously very simple. I'm just getting started. I don't know build arguments, so I see VSTS is actually already checked using the default build context. It's entered in image names with variables that it's set up for me, and I see qualify image name. That's good. Now I see that it's going to push with the build ID. I can just, rather than entering latest tag, I can just check a box.
Yep.
That's cool.
And it's a common pattern in the container world to whatever your latest image is, to add the latest tag as well. So it makes it a handy, easy way to grab whatever the latest is.
That's awesome. So now going over to pushing an image, do I have to go read through and recreate that service principal and that reauthorization?
Nope. We'll just grab it so we can see available service connections.
Awesome. So this is going to make it a lot faster.
That it will.
OK. And then I see the Azure Container Registry. Now it also, just like in the build, since I used a template, already has push an image as the action. I don't have to change the image name, and all I have to do is check a box for latest tag.
Yep.
So I'm ready to go.
We are ready to go.
All right, so if we hit save and queue, it's going to actually pop up with one more final box where it just allows us to confirm, do we want to use our agent queue? You can also use private agents, and while this is building, we'll talk about why you might want to. So he just queued off a build, and when we click the build, we can actually watch. So remember we talked about Docker files. We talked about layers and caching and pulling all those different layers, right? Right now, this is a very simple Docker file, right? It's a simple node app, hello world, essentially. It has one dependency of Figlet. There's not a lot of layers. But once you start getting into more complex workloads, and actually Abel and I did a session yesterday where we kind of deep dove into this. I did a recording of different container images on demand Channel 9 videos. And I demo bigger files where some of these builds can take 7 minutes or more because it's pulling so many different layers. And since this build agent is ephemeral, it's not going to cache that and be available for the next build. So in that instance, you might want to look at private agents so that it can cache those layers and make sure that each subsequent build is going to go nice and fast. Now, in this instance, because it is a very small Docker file, there's not a lot of layers, this build actually ran really quickly in about 30 seconds. Yep. But now we want to take what we just pushed up into the cloud. We still need to get it over into Azure. We now have it off our machine. The image is now up in the cloud, up in Azure Container Registry. We need it in Kubernetes. So it looks like right from within VSTS, we can hit release.
We can. And that's going to go and start scaffolding out our release process.
So our release management. Again, remember the DevOps practices we talked about earlier, release management, continuous deployment. So in build, I could select a template. Can I do the same thing for release?
Well, let's see. Well, we're in luck. So
looks like I can.
So let's see what that gives us there, right?
So glad that exists. So now for environment, I can just name my environment as I would, right? Like probably dev?
Dev, yeah.
Perfect, OK. So now I know that this is kind of bigger because we had to blow up the screen to make sure people in the back could see. But on the left-hand side for artifacts, we didn't actually hand off any artifacts over to release. There's no files we need for this. Again, in my demo yesterday with Abel, that was on best practices for Kubernetes, we did have things that we're handing off. But in this instance, we want to pull it from Azure Container Registry. Can that be an artifact?
It can. So what we have to do is remove this artifact, and then we can add a new one. And basically what the artifact is that's going to be the trigger for us to do our release management. So it's going to monitor the Azure Container Registry for us. And when there's new versions of the container that we're going to specify, then it will kick off a new release.
Cool. So it looks like we can actually select our registry, select the repository. We don't have to do anything with source alias. And if we just hit add, that adds it in as our artifact.
Yep. And I didn't have to re-auth. So that first time I connected to my particular
container registry and subscription?
My subscription, yeah. It's sharing that context throughout this whole process.
Awesome. Now, what's this little lightning bolt?
Oh.
So that's our continuous deployment trigger. So that's going to actually fire off the continuous deployment. So after we have this all wired up, anytime we make changes, we push to our Azure Container Registry, or we do a git push, because our build is actually listening, it's going to fire off the build, and now it's going to automatically trigger this release. That's pretty neat.
So we got that turned
But now
on.
we have to define the tasks, right?
We do.
OK. So when we click in there, so again, I see we've already named the environment. Under agent phase, do we have to choose our agent again?
We do. So by default, it's going to go to that hosted Visual Studio 2017.
But we'll want to make it match just our build, so we'll go ahead and do the hosted Linux.
So let's scroll up to that. There we go.
All right. And so now I see kubectl apply. Now, for anyone in the room who's still new to Kubernetes, you would probably use kubectl apply and then some sort of YAML file to apply your deployment, maybe the -f to specify the file. But when you're brand new to starting out, that can be a little overwhelming because you have no idea how to create a YAML file. You don't have to. You can run kubectl commands. You can do kubectl run, which is actually going to create the deployment for you. It'll create the YAML file for you. And it'll take the image and spin it up in what's called a pod or a container. And then you can create other things like services that'll actually make that pod and container externally accessible. And to do that, we would use the expose command. So Stephen's going to walk us through that.
So I've changed my command to run, and it changed my display name, so I don't have to mess with anything there. But now I have to tell this task how to communicate with Kubernetes. So I'm going to quick add new, and we'll give this little connection name.
OK.
And I have to specify my server URL, so I can get that from the config file that
when you run the az aks get credentials command, it's going to pull down a config file that's in your home folder, and then it's in a .kube folder, which is a hidden file, or a hidden folder, and then beneath that is a config file, which is, it looks a little like this.
Yep.
So You copy that over.
Yep, so you take this whole config file, which has all the things that you're going to need to talk to a particular Kubernetes instance, and you just drop that right into this connection.
You hit OK, and that's it. So now VSTS can talk to the Kubernetes cluster.
Yep.
Now, remember we talked about namespaces. We're not going to fill out a namespace in this instance. We're just going to use default. If you leave it to blank, it goes to default. But as you start getting more into Kubernetes, you can start playing with namespaces where your deployment, your secrets, your services, if you just attended Gabe's session earlier, your ingress controllers, all that would get put into like a namespace, almost like a little environment. But for the purpose of showing you completely simple, brand new, we leave that blank. And I see that while I was talking, Stephen filled out the argument. So what is that argument? You're doing kubectl run what?
Yep. So with the kubectl run, as you mentioned, we're going to create a deployment. I have to give it a name. So I'm going to call it hello build.
And then I see you're specifying the image with the image flag.
Right. We're going to point to our container registry that we push stuff to.
OK.
And I want the latest tag. And then I'm going to mention which port that we're going to be running our service on.
Perfect. And then now secrets. I mentioned secrets earlier. So that is a private registry, right? We need a Kubernetes cluster to talk to that. Do we? I don't know what the information is. Can I just add in a? Oh, look at that. OK.
Yep. So the task knows how to take advantage of your service connection and which registry you're going to point to, and it knows how to get it in the format that Kubernetes knows to use. All I have to do is specify, which subscription and which registry to talk to, and then just give it a name.
Awesome. So by the way, this has been asked in certain versions of sessions that I've given like this, is, well, what happens if somebody knows the name of the secret? They still don't have the information that secret is stored. All it is just a name. Yeah. Anything else, like your username, password, all that is hashed, encrypted, and kept in that. So just because somebody were to get access to your deployment YAML file, where you use image pull secrets equals my secret, that doesn't mean they can automatically reuse that and connect to your registry. It's specific to your Kubernetes environment.
So once we do this kubectl run thing, that's going to get my container out into Kubernetes, but it doesn't expose it out to the rest of the world to go hit. So we wouldn't be able to just go and call it over the web.
So that's why we have to create the service. And so he's going to go ahead and grab another task, because on the left-hand side really is just a task runner. And you can go into the marketplace. It looks like there's a Kubernetes task right there he's going to add. And now, again, just like you can select from apply, you can select run. Now he's going to go select expose. And what expose is going to do is it's going to create a service. So in Kubernetes, you have things like deployments, you have services, you can have persistent volume claims, you can have a bunch of stuff. But services is essentially creating that ability to access it externally or even route internally. Yep. So for services, you can have 3 different types. You can have load balancer, you can have cluster IP, and you can have node port. By default, cluster IP and node port are internal. Load balancer is exactly what you would think. A load balancer where it goes out to Azure, it's going to grab an IP address, it's going to make it to where we can access this container, this pod, but the service is linked to the deployment. And we're going to watch how Stephen does that.
Yep. So I do need to point to my service connection.
OK.
And I don't have to re-enter that. I don't have to re-enter that stuff again. It's all saved.
Perfect.
And then we get to our exposure.
So I see that you're doing, again, kubectl expose. You specify the deployment, which was created from run. You're specifying the name of it. It looks like for the type of expose or the type of service, you are telling it to make a load balancer. Mm-hmm. It looks like the port for that load balancer externally is going to be port 80. And then the target port, again, 3000, right? That's the port of our node application. Yep. All right. And then now I'm guessing there's also secrets again.
There are.
All right.
And so same way as before. We just pick from the available things in the dropdown.
Cool.
And
awesome. So now when we hit save, this is going to be able to save our CD or release definition. We're going to call our first release. This is a memorable moment.
It is.
Yay. And so now
and
that
you're
I've
all
saved
part of it.
Everyone's witnesses. It's official.
Yeah.
So when I hit release, now I can actually make this deployment run, right? I can manually kick this off to kind of complete the wiring and make sure this is all finished.
Yep. The first thing we have to do before we're allowed to do the release, though, is because we specified the Azure Container Registry as our source of artifact, we have to tell it what version to use.
Awesome. So I can actually select latest, because remember, when we did the push, we pushed with the build ID, but we also said to update the latest tag. So I know that I don't have to remember whatever the last build ID number is. The latest is always going to be whatever the last build was that was successful.
So we'll just create.
So it looks like it already completed or at least released the release. So it's starting the deployment. It's going to run through this pipeline.
Yep, and so we can link right into kind of the main page for the release. And we're going to hop over to the logs so we can kind of watch this in progress, in flight. And one of the things we've noticed, especially with the Linux agent,
they are in preview, is sometimes while you can watch it, every now and then you might have to actually press this little refresh button so you can watch it continue as it moves along.
Yep, like when it seems to hang for a little bit. In this case, it's not.
So this is cool. You actually saw the secret was created, the deployment was created. It's now starting the expose command.
Yep.
This is doing all that stuff that you would have to do manually on command line. It's doing it all for you. But this is in a matter of 10, 15 minutes from end to end, wired up, complete blank, node project, no Docker file, create a Docker file with VS Code, go into VSTS, create a project, build, push to ACR, go over to Kubernetes. And now, how do I see what was actually deployed?
So Kubernetes, AKS in Azure has a status dashboard built in.
Perfect.
And in order to run that, I have the Kubernetes config locally in my command prompt, and I can run the kubectl proxy command, and that lets me talk to my host, and it will tunnel the traffic out to the right place in Kubernetes, so it's not just publicly accessible.
The UI is an open API that you're automatically connecting. You don't have to know that. kubectl proxy is just going to create that link for you. So I can actually see, I see the workloads, I see the deployments. Everything's green. That's good. That means our image pull secrets work, the deployment works. I see pods. If we scroll down a little more, I'm guessing I'll start seeing services. Now remember, services is a load balancer, right? It's going to have to pull out, it's going to have to go out to Azure, it's going to have to pull that IP address, create that load balancer. So sometimes this external endpoint can take a little bit of time to spin up. So while Stephen waits for it to refresh, I'm going to flip back over to my computer.
Well, did you want to take a look at the YAML first?
Yeah, actually. So this is that YAML that we mentioned earlier. Remember, this is what you would normally have to write or manually specify to get the deployment working and metadata. And if you scroll down a little, you would actually end up seeing even things like image and image pull secrets right here. So we have image. We have container port. If you were to scroll down even a little bit further, I believe, we start seeing image pull policy, image pull secrets. You'll start seeing different things in the YAML file. But that's a lot of information to know how to enter. It's not something I would expect everyone to automatically know, which is why we introduce these kinds of commands. Yep. But along those lines, let me switch back over now officially to my computer.
Now you can go. Yeah.
How can you simplify that? How can you simplify the creation of YAML files? If anyone in here has ever written a YAML file and not had a space or indent errors or tabs errors, raise your hand, because I want to steal your magic. I want to steal your magic, sir. So it's obviously, it can get very hard when you're dealing with YAML files, especially the deeper you get into Kubernetes and you start having larger deployments, more applications, services, databases, load balancers, volume claims. You start having all these big YAML files, even ingress controllers. There's release automation tools to simplify the Kubernetes experience. And actually, again, Abel and I dove deep into it yesterday, so you can watch it on build, but we went deep into specifically Draft and Helm. Draft streamlines the Kubernetes development experience. So for every developer in the room, it streamlines your experience and makes all of these tools even simpler than that VS Code Docker extension. And Helm is the package manager for Kubernetes. So what does that mean? First off, Helm itself is the best way to find, share, and use software that is purposely built for Kubernetes. You can manage complexity. You can do easy updates. You can simply share because Helm produces what's called Helm charts. And Helm charts can be packaged up into little tiny tarballs that you can then use and hand off to your release stage. Or you can actually, very similar to image repositories, you can actually have your own Helm chart repository. So then you put your Helm chart up into a private repository. You start having your infrastructure as code. Not only do Helm charts reference your application, it references your infrastructure. It references your secrets, your security. It encompasses even the most complex workloads. And as a result, you can do simple things like rollback. I release something, it doesn't work. I can quickly roll back to a previous release with one command. Here's a visual of how that would look. So let's say I have multiple YAML files, right? I have CI, I have database files, I have load balancers, I have services. I have all these YAML files. I can put them into nice, neat little boxes that then Helm would use to deploy. So Helm has, and again, I dove deep into this yesterday, but essentially Helm is a local client. It's equivalent to what you would use with kubectl locally on your system. Then when you first run Helm, and you would run Helm init, it's actually going to set up what's called Tiller on your server. So Helm now uses gRPC to talk from your system up over into your server in Tiller. Tiller is then going to talk to the kube API, which is then going to actually trigger your release. So it's like the cyclical effect of dominoes. Again, using these DevOps practices. So if you want to learn more about Helm, you can go to helm.sh. Also, while I don't have a slide, if you want to learn about draft, bet you can't guess what that is. If you guess draft sh, you win. So you can learn more about both of these projects. They are open source. They are managed by Azure and actually the AKS and Helm team. They were originally started by a company called Deis. And again, dove deep into all of this yesterday, but Microsoft acquired Deis about a year ago. And I work closely with this team, trying to automate it. Everything's still new, it's beta, but it simplifies your Kubernetes experience. And the reason why I wanted to very lightly tap on that is because as of yesterday, and I think some of you might have seen it in the keynote, we talked about the Azure Kubernetes DevOps project in Azure. So Steven's going to actually walk through what that looks like, because if everyone in this room is overwhelmed with, OK, you guys showed me a lot of really cool stuff, but I don't have a container registry. I don't have a Kubernetes cluster. I didn't take a picture, shame on you, of whatever those commands were to spin up a cluster. How do I get started? I don't even have a VSTS account. How do I do all of this? And this seems really complex. It's not.
It is not. But before we jump into that, just to show you that press the wrong button.
Yep, hold on. I think you're over on 4, right? There you go.
There we go. All right. So I just refreshed our dashboard here and from our deployment, and I have an external endpoint. So let's see if our app came up. Woohoo!
So that was the end-to-end deployment live demo. Yes, the demo gods were with us. But now we want to show that AKS project, right?
Yes. So I'm over in my Azure portal, and it's pretty easy to get at these. We just go to create a resource.
OK.
And in the popular section here, just below the fold,
DevOps is popular.
we have DevOps project. So I'm going to select that. And it's going to go through, and there's a wizard. It's going to ask me about it's going to have 4 screens of stuff to answer. Let's create a .NET project.
OK. Probably smart. We are at a build conference, right?
Right.
C#.
And we did Node.js. Now let's do a little .NET. And let's do .NET Core, because we like to go cross-platform.
Yep.
And open source.
Especially since our background is open source.
Right. So now I can pick where I'm going to deploy this to. And I could go to app service. I could go to a virtual machine. I could run a Linux and web app. I could do a container on app service. But now we have this Kubernetes service. And
so
since that's what we're talking
let's just read this for anyone in the back of the room that can't. It's a fully managed Kubernetes container orchestration service for managing containers without container experience. If you were the person that 5 minutes ago was just thinking, this is awesome, but I don't have any of this, this is for you.
So then we'll do next again.
Look at that. If you're also the person that says, but I don't have a VSTS, we got you.
We got you covered, right? So here we're going to either specify some information to create a new one if we don't have one, or we can reuse an existing account if you already have one. I have one, so I'm going to use my existing account. And let's give our project a name. And it knows what subscription I have because I'm logged into my Azure portal. And it's going to give our cluster a name based on the project name and region to deploy it in. And I'm going to choose done. Now, this is going to go off, and it's going to create that cluster. It's going to create my container registry. It's going to set up my source control. It's going to run a build and a deployment and go all the way through.
So it does, again, everything we just talked about for you. It sets up that CI, CD, everything we did manually. It set that up. It's setting up the ACR. It's setting up the AKS. There's truly nothing that you would have to do. But that's going to take a little bit of time, right? It's setting up a lot of stuff. And we don't, unfortunately, have a lot of time in the 11 minutes remaining. So can you show us what that's going to look like?
Yep. So what's going to you can see the creating one on the dashboard there. There's also a link to the one that I've already created. And so we're going to go to that page. And you get a nice landing page that has some information about your CI/CD pipeline, the current state of things. It has a link it's got a lot of deep links into the various steps, including the source control repository, the Kubernetes service. It's got a link over to the application that's running because it did a full deployment for us. And then at the top, too, it also has links for us back over to source control, build pipeline, release pipelines. And one thing we didn't talk about yet is it also wires everything up for App Insights.
Remember the fourth part of DevOps, right? We talked about monitoring. We talked about getting that data. How can I know if I'm actually delivering value? I just released a feature that I thought was super cool. How do I know if everyone else actually thinks it's cool?
Yep.
Application Insights gives us that telemetry.
So we talked about it scaffolding out build and release pipelines. Let's see if they look anything like what we just talked about before.
Or the demo that we set up for you.
So this will take me right over into my VSTS account, right over to the project pipeline, and we can take a look at the build definition. And it's going to start out very much like what we had before, but it adds a couple of things here.
So it's starting to add that Helm, right? That's the package manager that I talked about. So the reason why I wanted to end on this is I wanted to bring the story full circle. So as you start getting into it, you've started to run the demo maybe with kubectl run, kubectl expose. You've set up your own pipeline. You're ready to dive a little deeper. This will show you the scaffolding and set up your environment with Helm. So you can learn from best practices, right? So again, this is still using an agent queue with hosted Linux. But for Helm to work, it's a command line tool. That's what I told you, right? It works on the end user system. So you can set up on the build agent to install Helm. And then to set it up for client, because VSTS is actually going to set up that gRPC call, it's going to set Helm up to talk to your cluster, to talk to Kubernetes. And then it's going to have Helm package to take those charts we talked about, all those YAML files. Essentially, the YAML files with Helm are templatized versions. And you have one YAML file. It's called a values file. That's the knobs and dials. So you fill out anything that you're going to need, that you're going to reference multiple times throughout your deployment. You fill it out on values, and then the sub-templates or the sub-charts go and reference what's in values. Again, to deep dive into it, please check out the build session. But VSTS has set it up all for us. Azure has set it up all for us. So now if we go over also to our release, we can see how that's looking very similar. So we can take a look and see that with our build, we have very similar tasks. We built an image, we pushed an image, we packaged up our Helm charts, but rather than running kubectl commands to run and expose and only do two things, we can use Helm to do everything. That means we can stand up our service, our deployment, databases, persistent volume claims, ingress controllers, image pull secrets, even if you wanted to have a YAML for that. You can do everything. And again, it's going to set up on the release agent, on the release computer, Helm. It's going to initialize that. And then it's going to go ahead and run the Helm upgrade command. And if you click, actually, Stephen, can you click the Helm upgrade command?
You bet.
And then scroll down a little bit on the bottom. Keep scrolling, keep scrolling, keep scrolling. Pause. All right, so then it even has a box where you can check, install if release isn't present. This is that rolling upgrade we talked about. So because the basic commands that we talked about with kubectl run and kubectl expose, those are one-time commands. You try to rerun it, it's going to error. It's going to say, nope, actually, this release already exists. You're going to have to delete that deployment and redeploy. But with Helm, it allows you to do Helm upgrade. And if the release is not already present, go ahead and install. And with VSTS and the extension for it, it makes it super simple because it's just a little checkbox. And you can even locally right here specify your value file if you wanted to override. And the values, again, will make sense as you dive deeper into Helm.
Yep, but what's great about this is it gives you a pipeline that you get to own and you get to play with, and you can start with just a .NET Core app, and you don't have to change any of that.
You can drop your own code.
Yep.
If you have a .NET Core application, you can drop it in to code, which, again, the screen's a little squished right now, but if he were to go to his code instance for VSTS, which you can easily get to, I guess, from the dashboard, if you go into that, you can drop your own code into that repo and have it build, and then the C# application or the charts is actually going to build up your Helm chart deployment, and voila, you just created your first Helm chart without really having to do anything. VSTS did it for you, and Azure did it for you.
And just to make sure we have a working application,
That was our DevOps project with .NET Core. So again, I mean, and even this IP address, if you dropped in your own code and it kicked off a new build, you would end up seeing your application there. So it empowers you to do all these things without having to know, essentially, how to write any YAML or Docker file.
It lets you be successful and then start learning.
So ultimately, that is the end of our session. If you do want to connect with me or connect with Steven, you can send me an email. You can hashtag, obviously, LOECDA. Follow me on Twitter, @JLDean. Remember, no relation to James Dean. You can also follow my blog. I blog really heavily on all this. Everything Kubernetes, everything Helm. Yesterday, by the way, I kept mentioning words, ingress controller, load balancers. Obviously, if you have multiple apps with multiple services, you're probably not going to want to have multiple IP addresses and multiple load balancers. So you probably have an Nginx ingress controller and routing and hosting and all that. While I was giving my session, my blog post went live where I talked about how to use SSL certificates with an ingress controller, all set up from Helm charts in a Kubernetes cluster. And I walked you through all of that in the blog post. And I think my blog post before was another Kubernetes session. And then before that was probably, again, still Kubernetes. Also, you can check out the LOE CDA website, where we have a list. If you click on Talks up at the top, it's a list of where every single member of the league, all 5 of us, are going to be throughout the year. We are constantly updating it. Finally, most important, please complete an evaluation form for every single session you attend. I cannot tell you how important this information is. It gets back to us. We can learn what we did right and where we can improve. Thank you for your time. I think we do have a few minutes, probably about 4 minutes, to take maybe 3 questions, depending on how long they are. And then otherwise, you can find us at the lounge, or you can find us outside the room so we can free the stage for the next group of presenters. But anyone who wants to ask a question, feel free to grab the mic. We'll hang out here for about 4 minutes.
You want to step over to the mic there?
Hi.
Hi.
Is there a way to export the configuration that you showed for the pipeline that we built and recreate the pipeline?
Sorry, what was that?
Okay, I'm sorry.
Is there a way to export the configuration of the pipeline and recreate the configuration elsewhere if you
In
want
VSTS
to?
exporting.
Yeah, so yes, there is an export option on the, let's see, this is the release. Oh, yeah. So,
That might help.
yeah. So look at the build pipelines.
So I think when you click right over there,
Yeah,
yep.
there's an export option. And if you, there's an export for release as well. And the other option you have is you can do the view YAML, and then you can put your build definition in your repository along with the application.
So again, still like infrastructure as code, doing good practices. Did you have a question?
Going through the Azure portal and using the DevOps project to
Yes.
create it, can you do that where it creates the tasks automated with on-prem TFS instance, or is it VSTS only?
I believe right now it's TFS only because most of the features that are in VSTS, usually every 3 months or so is when they bundle all those features up and push it out to TFS. So the Helm task just came out it's May 9th. It came out April 24th, about 3 weeks ago, if I did math correctly.
Okay.
So a lot of these features are still brand new. A lot of this stuff is still bleeding edge. The VSTS team is also here, so they can correct me if I'm getting this significantly wrong. But my understanding is that any of the features that are in cloud will eventually get over into TFS on-prem.
Now the creation of a DevOps project is not going to target your TFS instance, but you could create one in VSTS and export the definitions.
And then bring it into TFS.
Yeah.
And you would have access to like the same tasks and all that stuff once they get over down the pipeline.
I just saw they released they announced the update for update 2 recently. So
Okay.
cool. Thank you.
You're welcome.
Exporting configuration as well. What about all the resources in Azure, ARM templates for creating a DevOps project and having a template for redeploying all of that once more?
So you can also export your ARM templates as well, right from Azure, as you would any other way. I also have on my blog blank ARM templates if you want to use to construct your own Azure Kubernetes instance. And I have 2 different versions. I actually partnered with Lena Hall, who, by the way, anyone who's left in the room, go follow Lena Hall. She's amazing when it comes to distributed systems, high-skill data, big data, all that stuff that I don't understand. But we actually partnered together to write the ARM templates for both service principal name or if you wanted to use Key Vault. So those templates, blank templates, ready for you to use, put in your infrastructure. You can take a look at what was deployed from the DevOps project, take a look at those ARM templates, kind of pick and choose, and make your own that makes sense for your workload and your environment.
Okay, cool. Thanks.
You're welcome.
Go ahead.
So when you did the authorize from the build pipeline, did that work because you had access to the subscription with the ID that you were logged in with?
Yes.
So is that now every time it runs, running as you, as your identity?
No,
It's
it went
creating
out
a
and created a service principal. Sorry, go ahead.
No, so it creates a service principal in the Azure Active Directory for the accounts that you have permission to. So I picked that. And so it's not running as me, it's running as a service principal that I created.
So you can still have control over that. If you wanted to pull that service principal, you can go into your Azure subscription, go into your Azure AD, and you can actually delete that service principal.
So did you also have to have rights to be able to create that service principal?
Yes.
Okay.
Yes, though I think those are pretty. At least I haven't had a problem in any of the subscriptions I've been in. But yeah, I'm sure there is a well-defined permission for that. Yeah, I'm getting some emphatic nodding happening here.
Any
So.
other questions? We have 15 seconds. Nope, we're over time. Never mind. And if you have any more questions, please find us outside in the hall. I was like, wait, that
Thank
time
you.
is
Yeah.
going up,
Upwards,
not down.
yeah.
Thank you very much again.